Welcome back to the Make Above, and today we're going to be welding an aluminium flange using a standard Bossweld MIG welder. We're going to start off by cutting up the tube on the bandsaw, and then we're going to take it to the lathe to square it up, take it to size, then over to the welding table to fixture it and weld it together. I've had some trouble cutting thick aluminium pieces with this bandsaw, so what I'm using is some cool cut dissolvable oil inside a squirty bottle, and I'm just adding liberal amounts of that to ensure that the blade doesn't stick or the aluminium doesn't get caught in the teeth. Our target dimension is 80 millimeters, and there you can see that we're just slightly over. So now we're going to take it to the lathe to square up those ends because they won't be cut dead straight, and also to take it to its final measurement. Now, I'm just a hobby machinist and I'm not sure if this is the right thing to do, but I did feel a little bit nervous having those jaws all the way out that they are, but the part was held in quite securely, so I think it was safe enough process to do. But if you got any comments on whether that's safe or not, let us know. My approach here is to try and machine both sides of this tube so that the ends become perpendicular with the tube as much as possible. And then I'm going to slowly creep up on the dimensions so we can land on exactly 80 millimeters. The part that this is for has no space for tolerance, so probably better to be slightly undersized than oversized, so we're just trying to make sure we get it as close as possible. And of course we're chamfering the edges because this part has to fit back inside some flanges and then be welded in place. And here we are. I'm very happy with that. I am just using calipers here, but I verified it with some micrometers later, which I didn't record, and we were just slightly undersized, which is where I wanted to land. With the turning complete, we just give it a deburr on the inside, just so there's no sharp edges when handling, and then we'll head over to the welding table and try and fixture this up and get the flanges aligned correctly. Here's our first look at the drawings, and as you can see, the flanges have an orientation. Now the engineer has given me a feature which can help me determine that I've got the flange in the right orientation. So not only is there an orientation of which the flanges have to go, but the flanges don't have any features other than the specified feature to align it up so that those bolt patterns are in the correct spacing. So here we are just trying to line it up now, and we'll just do a dry fit here, and then we'll fixture it down to the table and do our first side, then reline it up and continue to weld it. Here we can see my concept of how I'm going to line that feature up. I'm using a bit of silver steel that is very straight, and then I'm going to use a square to try and line that up so it's as straight as possible to the table, which I know is fairly flat. That's the concept. When doing this just by itself, it seems to be kind of straightforward, but as we'll see when I'm trying to do it with all the clamps in place, it's proving quite difficult. I'm just fixturing it down. I've got it together, but I know it's not aligned correctly at the moment, or at least the two flanges to each other. So just doing a fixture to line it all up and make sure that that flange isn't going to warp as much as possible. And then we'll talk about the welding setup. So here's my welder, which is an MST 185 made by Bossweld. Now I've got argon gas hooked up to it. I've put a little spool of aluminium Bossweld wire in there, and I've turned the settings of the welder up to max, so max wire feed and max voltage. It is also important, if you use this welder for welding steel and that sort of stuff, to swap out the tip as well as the gas shield nozzle. And this should prevent some contaminations getting into your weld. Not all of them. MIG welding aluminium doesn't seem to be as easy as it is to weld steel, but as you'll see, it's definitely something you can do. And I guess I'm using weld in a loose term. I'm really tacking this together. It's not super structural, it's just a spacer. So the actual tube itself is what's doing the spacing, and the flanges are just to key some components in place in the right orientation. Now, some people may notice I've stuffed up here. I haven't actually prepped the surface but I'm going to go ahead and tack it anyway, and then realize that and take the clamping back off so I can clean the area as good as possible, and then go back and do another tack. There I was just looking at that tack going, oh, that's very raised compared to my test tacks I was doing earlier. And I'll repeat it again and then realize that, yeah, I didn't clean the surface. And then I'll come back through after wire brushing that surface with a stainless steel brush that is only for aluminium. That was something I learned very quickly, is that you have to have a stainless steel brush that is just for aluminium. You cannot use it to do anything else. Otherwise, you're just going to end up putting iron filings into your aluminium and get a very bad weld. Now, when I'm actually trying to tack these together, I'm putting a lot of heat at the start of the tack into the tube because it's a lot thicker than the flanges. And then I'm rocking that pull down and then sinking it into the flange itself. And I've done a couple of test pieces before doing this one, and I found that that was quite successful. Now with that side of the tube welded, I'm just spinning it around so I've got easier access to weld the other side of it, making sure I clamp everything down as well as possible, covering the little holes that bolts have to go through as much as possible so we don't fill them up with weld. And then we've got the first side complete. Now we've just got to clock in the top flange and try and weld that one in place. Here I'm trying to align it just on the table to make sure it's possible. I can twist the right parts around so that it actually moves. And then I realize that there's no point doing this. It's just moving as I try and move the workpiece around. So I go and clamp it in fully and try and do it. And then I've realized that's quite difficult to try and use my eye to align it with the square, but that's how we planned it. So managed to get it to work. The funny thing about all this alignment is it actually took way longer than doing the final welding. So yeah, if you've got a better way of aligning something like this up, maybe I should put a couple of extra holes through the piece that I can use for pins and then fill it full of weld. I'm not sure, but in the end the part worked. I'm very grateful for that, but definitely some learnings from this one. And here's what it looks like just after I've finished tacking it all together. As you can see, there's a lot of soot from the welding process. There's a lot of white residue left on the table as well. But we'll head over to the lathe and we'll try and clean it up a bit and show you the final product.